Another GigaOM webinar. This is Andrew Brust with GigaOM, and our sponsor today is Couchbase. Our topic is operations and analytics united, not divided. And by that, we really mean sort of to tackle this idea about databases that are optimized for operational use and other platforms that are at least allegedly optimized for analytical use, and how we can really kind of approach that segregation and try and harmonize things better than they might be in more traditional architectures. Again, I'm Andrew Brust. I'm a lead analyst focused on data for GigaOM research, and data these days really means everything about databases and BI and analytics, and more it also means machine learning and AI. I also cover that space as a journalist blogger for ZDNet and do direct work with customers in the space. Our guest today is Sachin Smotra. He is the Director of Product Management at Couchbase. So first of all, Sachin, pardon me, I'd like to welcome you. Second of all, I'm hoping you can expand on that title a little bit. Tell us kind of what your day-to-day is like as Director of Product Management, and also maybe give us a sense of some of the things you've done prior to that, so we can get a sense of you know, where you're coming from philosophically and industry worldview wise.
Sure. Well, thank you, Andrew, and welcome everybody to today's webinar. Again, my name is Sachins, and I am the Director of Product Management here at Couchbase, responsible for the analytics and the mobile product lines. As a part of my job, the first thing I do is work very closely with engineering and getting releases out, which is why I think if there's anything you need in any of our product lines, I'm the gatekeeper for the product lines that I own. And then I work with customers on understanding what their pain points are, identifying how we can address those pain points, and then go through the process of essentially rolling out the product in multiple customer locations. I've been at Couchbase for around 3 years now. And prior to joining Couchbase, I was a part of the WebEx product management team, where I was responsible for the go-to-market outside of North America. And did a bunch of fun stuff with NoSQL databases in trying to get operational intelligence on what was happening in the WebEx world. Prior to that, I worked with a bunch of startups in different roles ranging from engineering to partner management and product management.
Excellent. And that's interesting about the WebEx stuff, even though we're not on that particular platform for a webinar today. I'll look to you for any technical support I might need if things go a little haywire, which they won't, of course.
You got that support in the house.
I'm sure you had similar requests from family and so forth when they were trying to join their web meetings. In any case, let's talk about the actual data stuff here. And what we want to do, I want to talk about, you know, what we're going to talk about and also how we're going to proceed. So we want to level set just by getting some definitions down. OLT, OLAP, and ETL, they happen all to be acronyms. So we'll want to expand those acronyms, but we also want to explain them. The OLTP and OLAP represent different workloads. The question is, does that mean they need to be implemented on different platforms? And that'll be the next part of our discussion. Moving from between platforms typically involves data transformation, and that's been around and with us for a very long time. And there's lots of valid ways of doing it. There are also some downsides, and it will make sense for us to explore that. Then this notion of operational analytics, of bringing these workloads together on a single platform, we'll want to talk about how that really happens and what some of the benefits are. We are also going to have a couple of polls as we go through. That's really Sachin to help you and me understand the audience a little bit better in terms of gosh, their sort of deployed environment, their plans, and to some extent their their opinions and philosophies. You know, it's a little tough in a webinar to get a good sense of the audience. We can't have literal eye contact, but these polls can help make things a little bit more intimate that way. So we'll have a couple of those. And then, of course, questions and answers. Gosh, when I started as a speaker in this world, I always wanted to leave those to the end. I've completely 180'd on that, and I like to blend the questions into the conversation as they come up to the extent possible. If it feels like we're going down a rabbit hole, I'll probably move on. But even in that case, if we have kind of a deficit, we'll have some dedicated Q&A time at the end. But in a perfect world, we'll be taking these as they come, and when we get to the end, we'll be zeroed out on the question queue. We'd like to encourage everyone in the audience to use the GoToWebinar console and answer your question that way. They'll get relayed to us, and I'll try and stitch them into our conversation as best as possible. So with that said, let's proceed. And again, the idea here is to nail down some of these 3- and 4-letter acronyms. And Sachin, if it's okay, I'm hoping you can go mostly from left to right here. And I'll ask for your forgiveness if this lays out a somewhat simplistic view of the world, because usually there's shades of gray and there's nuance, but kind of at opposite ends of the spectrum, we have a couple things, and then we have a technology to help us to get from one to the other. Could you give us a little insight on that?
Sure, absolutely. So I'll start with the extreme left, the whole notion of online transaction processing. I'm sure the term is not new to people anytime you're interacting with your database. And when I think of operations, I like to think of it in terms of, let's say, a use case. Let's think about a shopping cart use case where customers are interacting with the database and adding stuff onto the database to their shopping cart, or removing stuff from their shopping cart. So those are all examples of operational workloads that are hitting your database and essentially making changes to what people are buying on your e-commerce website. Then from there, we come into the notion of OLAP, or online analytical processing. Databases that are custom made for analytic work, and this includes the notion of warehouses, the notion of data lakes, the notion of OLAP cubes, depending on what organization you work for. But the key thing that is happening is that there, instead of a customer trying to add and remove stuff from their shopping cart, you're actually trying to analyze customer behavior. What are the items that are in shopping carts, let's say in the last 20 minutes or so, that have been removed or have gone out of the number of those items in the inventory has gone low, or any other example of what you'd like to know about what's happening broadly in your business. Again, in trying to marry those two separate worlds together, there is this whole notion of ETL, or where you extract data from your operational database, transform it into the form that makes sense to your business, and then load it into your analytical database or your OLAP database, and essentially start to ask questions related to that data. Now, all of this is great, but there's this whole notion of operational analytics, and this term is slightly overloaded. If you think about the traditional definition, which I realized after I started speaking to many customers, people think of operational analytics as being IT operations, where if you have a server farm and you have a bunch of machines sitting out there, you're getting logs from different machines. If some machine has gone down, or if some hard disk is failed, then you have the analytics in place to essentially streamline your operations. But the notion of operational analytics is much broader. I take the example of, for example, the customer shopping cart analysis. If you wanted to find out while customers are moving stuff from different shopping carts on your website, what's happening exactly on your business in the last 10 seconds or in the last 5 seconds, then the notion of operational analytics is not just about logs going into a log file and then being able to essentially figure out if a machine is up and down. It's more about having access to the application data in a matter of milliseconds, if you will, and being able to analyze, which in more technical terms means querying that data and trying to figure out what business insights you can glean from that data.
So I'm reminded of the sign on the highway or at the side of the road that says, if you lived here, you'd be home by now. It's a little bit like that with operational analytics, right? We have the we have the operational data, and if the analytics lived there, it would be home right now, and it wouldn't need to move, and it wouldn't necessarily need to be transformed. Forgive me for interjecting with that folksy example, but hopefully that helps a little bit. Please also give us your thoughts on ETL.
So ETL, the biggest challenge with ETL has been the fact that ETL is a bunch of processes that need to be planned. So you need to understand how your data is coming into your transactional workload, figure out what questions you want to ask from that in your analytical systems, and then to bridge that gap, you want to have a pipeline that's going to be built in place that's essentially moving data from your operational workload or operational system into your analytical system. Now, these pipelines are fairly complex, and they are very, very difficult to manage. In many cases, what is also happening is that because of the modern architectures like NoSQL database and with support for JSON documents, the agility of the application is enhanced dramatically because there's no schema enforcement on the document database side. As a result of which, your application is evolving really, really quickly, but the ability of the analytical side of the house to keep up with application evolution is really, really hard. And by bringing in that ETL layer, if you will, in between the two types of databases, you're essentially transforming data that is stored in one format into a completely different format, where you lose some of the richness of the data that you might have had in the native format that you were storing it on the transactional side of the house. So ETL processes are not, I mean, it's a multi-billion-dollar business for sure, but these processes are extremely complex and they are difficult to manage. And what we've heard from our customer base is, as we talk about examples like shopping cart analysis, examples like connected cars where there's data coming in from all the cars that are on the road, they don't want to wait for any sort of transformation before they can start to query that data or ask questions of that data from an analytics perspective.
All right. Well, we've got all the pieces laid out and a little bit of a traditional workflow maybe in our head. Now let's let's try and get some more insight. Now, actually, it's our turn to ask the audience to kind of comment through voting, through multiple choice. And we're just interested in what you've got deployed now in terms of both the operational side and the analytical side. So this is a select all that apply. You needn't pick one. You should probably be checking at least a couple. Relational OLTP, or relational database for operational use, NoSQL, data warehouse, most likely also relational. Are you doing enterprise BI and OLAP? Are you using cubes? Are you using a back end from a traditional BI company or an enterprise kind of software mega vendor? And then finally, are you using data lake technology, be that Hadoop or Spark or gosh, other things apply here too, like Presto. And by the way, it doesn't say this on the slide, but this can be, in each case, this could be on premises or in the cloud. If you've got one or the other, go ahead and check it off. So the poll's open, and we'll be asking you guys to click in. This will give Sachin and I a better understanding of where things lie. In these webinars, we get to talk about ideal architectures, but we understand that the reality is different. Everybody's got some legacy. Everybody's got some stuff that probably predates their tenure at the organization, and you need to work with that. There's important investment in that. There's sunken costs. You've got to take advantage. And so it helps us to understand what it is you're working with. And we'll give this just a little bit longer and then take a look at the results. That should get us to a good place. You know what I find often, Sachin, is that despite perhaps a portrayal of it as old-fashioned or outmoded, that enterprise BI shows up with higher numbers than people sometimes expect. We'll see if this bears that out, or if it ends up making me look silly for even mentioning it.
Now that you said that, I think I'll throw it out there as well that I've seen a whole bunch of customers try out different things with the data lake initiatives, whether that's based on Spark or that's based on Hadoop. And I'd be very interested in seeing what the number of attendees here have to say about data lake initiatives. Because in many cases, what I've seen in our customer base is the fact that a data lake is not really a data strategy. When you're putting data in the lake, because you have the flexibility of schema on read, you can basically treat it like a kitchen sink and throw whatever you want in there. And many times, while that is great in terms of storing data, as far as deriving value from that data is concerned, that is always something that ends up being a question mark. And then you have
I'm sorry, go ahead.
And then you have this multi-million-dollar project that needs to be started to essentially try and get some value out of tons of data. And I'm thinking terabytes, petabytes, even exabytes of data that people are beginning to store.
I think the thing about there's kind of an irony around data lakes is that to work really well, I think customers need to be very proactive in how those lakes are structured and populated. And then meanwhile, lakes tend to be kind of a default parking spot for data that people aren't sure what to do with. So those two things are at odds. In any case, we have our results. And enterprise BI is not the smallest bar, but it's not the largest one either. So I'm not sure what that says about my pontification there, but lots of relational OLAP and lots of data warehouse. Data Lake and NoSQL are not insignificant components here. And later on, we'll get a sense of what people are planning as well. So that'll let us go kind of full circle. In any case, let's move on here. And now let's try and blow apart this idea that different workloads, and here we're talking about OLTP on the one hand and OLAP on the other, do different workloads necessarily mean that we need separate optimized platforms for each? Well, the subtitle kind of already says no, but maybe you could elaborate there. What do people have as a default kind of expectation or assumption, and what ends up kind of working best in practice?
So what we've seen based off of our conversations with, and I'm talking about some of the largest enterprises in the world use Couchbase today. In fact, I think we're in 30% of the Fortune 500 companies, if not more, as of last week. What we've seen is that the adoption of NoSQL has essentially been because of performance, availability, and scale that it brings. More importantly, also the ability for developers to build applications in an agile fashion. Something that would require schema conversations in a relational world would mean that there'd have to be a committee, there'd have to be agreement across multiple people, multiple stakeholders, multiple groups coming together and then agreeing on what the change should be, and then that change has to be managed very, very closely. But as this new breed of modern applications are being built, and with this schemaless world of JSON, we've seen that the agility of applications and the developers to build those applications has increased manifold. But many times on the analytical side, that has not kept pace. And that's because there's always this transformation process that's sitting in between. And even if the operational side of the house is evolving really, really quickly, getting to those changes or getting new attributes that are being added on the operational side of the house to the analytics side of the house is always more complex. The key concern that we've heard from pretty much each and every team, and this resonated really well with all of our customers, was that I do not want to be doing any sort of analysis that's going to come and interfere with my operational workload. Let me give you an example. Couchbase is really popular in the hotel industry. A lot of the leading brands use us for essentially managing bookings on their websites. And while they would love to analyze how hotel rates are trending, whether they should increase their rates, input into their pricing engine, or how hotel bookings are essentially trending from a season perspective, the last thing they want is any of this complicated analysis coming down to impact their e-commerce experience or their website experience. So what we heard from them was a resounding yes in terms of having nodes or having the ability to isolate my analytical workloads in a way that is custom built for analytical processing itself without having any impact on the operational side of the house. And what that meant was that there was a way to manage that in a single platform. That would be a huge win for teams that have essentially embraced this modern way of development. So instead of having to then go and move from one system to the other to essentially deal with application evolution, if all of this was being managed in one single platform, then the whole development process was a lot more simpler. And then the ability for organizations to derive insights, the rapidity at which they're able to derive that insight increases manifold again.
Got it. So the last two little rungs on this ladder here, the notion of dedicated resources on the one side without separate platforms on the other hand, could you, and you, I mean, you kind of already talked about it, but could I get you just to, for people like me with thicker skulls, if you could just sledgehammer us, what does that mean? Because you know, a superficial read of it makes it sound like a contradiction. But
yeah, absolutely. Let me go a little bit deeper into that. So I'll take again the example of, let's say, an e-commerce application where you want to do shopping cart analysis, and let's say you've embraced NoSQL or a document database, a JSON document database as your database of choice because of schema flexibility and the agility and the performance and availability that it affords you. Now, anytime you want to analyze that data, what you're doing is you're moving it from the operational workload where, let's say, you've got 10 attributes that you're using to identify a customer, and then you have all the attributes of a shopping cart. Let's say what's the type of item, whether it's a vegetable, whether it's an electronics item, and so on and so forth. Again, I don't want to go into details of how you would model the shopping cart. But essentially, that is something that could evolve really, really quickly. On the other side, if you're, let's say, using the traditional data warehousey approach for running analytics on top of that data, then what you would need to do is anytime you make a change to your shopping cart data model, you need to be able to make the exact same change on the data warehouse that you've got designed for analyzing that shopping cart data model. Now, that is where there's an impedance mismatch, where on the operations side of the house, you have a JSON-based schemaless database, whereas on the analytical side of the house, given that traditional data warehousing is all relational, you actually would need to go into schema design to start with, then schema redesign and evolution as and when you make changes, which is where the ability of the analytical side of the house, especially if you're using a relational data warehouse, is really, really not able to keep up with how applications are evolving on the operational side of the house. So let me pause there and see, Andrew, if that is a better explanation of why we need dedicated resources per workload right now, and how that is a little bit harder with a traditional approach.
Right. All right. Well, that's good, because we know that there are, you know, database administrators and others who while they appreciate the need for analytics, are very understandably protective of, you know, the lack of contention for resources to keep things operationally smooth. And I guess the point here is you can accommodate that legitimate need without having to go to the extreme of having a totally separate platform where the data has to be piped over. Speaking of data being piped over, let's talk about data transformation, and really kind of what we mean here is ETL. This is, again, it's not new, right? If I go back 20 years, when I was first learning about OLAP cubes, you know, I understood that I had to take data from a normalized structure, move it into either a warehouse or staging tables that had more of a measures and dimensions structure, and then I had to load the cubes. And then, by the way, I had to worry about updating those cubes at some regular interval so that the data in them wasn't too stale. Gosh, with all that set up, does that translate? Does that does that translate to a counterpart situation today? Number one, and number two, you know, how has that scope changed? We're not just doing a relational database to a cube anymore.
Right, and that's very true. In fact, I think the big challenge that we're seeing is that from the normalized to the star schema that you just described, there's been evolution on that front as well. Most modern applications are evolving from using, depending on the use case, there are many cases in which NoSQL technology is being embraced, and then the whole normalization of data on the operational side of the house has been replaced by denormalized data, especially with NoSQL being support of JSON documents. Again, transforming a JSON document into a cube is, like I was describing before, a really, really complicated process, but is also a process that is very brittle. It is fraught with brittleness because anytime you change anything on your JSON document, which is very simple in terms of being able to add new attributes to a JSON document, you need to then go back and figure out how the schema on the cube is going to evolve and how you're going to measure these new dimensions, if you will, or new facts that are being stored right now as a part of your JSON document. And there again, you need to, as you store more data, you need to get a bigger cube, and the costs of managing the whole transformation from a native JSON format into a format that is based for relational databases is extremely different. Now, as a part of this whole process, like we said, one of the key concerns from IT teams is that there should not be any latencies introduced or in the operational workload. As a result of that, there are many cases where there is batching involved, where from the operational side of the house, you are essentially going to wait for, let's say, when your traffic is low, or wait for a certain amount of time for your resource utilization on your machines to go below a certain threshold before you send over data onto the analytical side of the house. And this whole notion of the ETL pipeline, where you're bringing in data and then from one side and moving it on to the other side, they not only have to be built, but it's the whole maintenance and management of that pipeline that is a really, really complex and a costly operation. Now, what that means is that anytime you want the logic in your pipeline to change, that's a brand new project which requires its own dedicated set of resources. And then by the time you get those changes made, your application might have gone ahead and evolved to, let's say, a new version of the schema. So the ability to keep these two different sides of the house in sync with each other is extremely, extremely hard, which makes this whole process a lot more brittle. So this is definitely not the data nirvana which we're looking for. In fact, the nirvana state should be that whatever I'm storing in my operational database, if there was a way for me to get access to it on the analytical side of the house without doing too much work, and in a matter of not seconds, but milliseconds, and in some cases sub-milliseconds, then that's where I would like to, that's where from a data management perspective, the state of nirvana would be achieved or accomplished. Andrew, what do you think about that?
Well, yeah, I think, if we can eliminate the more moving parts and we can eliminate in the shorter distance between, between repositories, the better. I was going to say, even in the bad old days, even when the requirements didn't change, just the operational notion of the job running was kind of a nail biter. I mean, a lot of these load jobs ran overnight, and so you didn't really know if there was a problem. You didn't even know that quickly. You kind of woke up to bad news, and that could, I don't know. I spent a lot of years in consulting. That made for a lot of angry customers, especially as the analytics that we built for them became more appealing to them. It also became more mission critical and very disruptive if something didn't work. So just out of a sense of conservatism, I feel better, simplifying things and streamlining things and making things less Rube Goldberg-like. And again, that was well before we had, JSON and document stores.
I'd like to quote an example of like a customer of Couchbase in the e-commerce space that wanted to do shopping cart analysis to figure out duplicate items in the shopping cart. And because the shopping cart schema was changing dramatically, or it was changing on a very regular basis, the analytical side of the house was not able to keep up with it. Now, the challenge with that was that anytime there was a duplicate in the shopping cart that would be shipped to the customer would receive 2 of the same items and then come back and call customer support and say, you know what, I did not order 2 of these, I need to return 1. So the whole cost of, number one, from an experience perspective, the customer experience was really, really bad. Think about Black Friday and ordering 1 Barbie doll, but instead getting 2, and then not knowing what to do with the second one, and getting charged for those 2. So the painful process of picking up the phone or going to the website and then putting in the details, getting your order, and then saying that there was a duplicate item that was shipped out. And the whole notion of managing the logistics of receiving all of those items on the back end was extremely costly for the e-commerce retailer that I'm talking about. So the impact on the business was so huge that they needed this ability to essentially start to analyze shopping cart data as it was being fed into the delivery and fulfillment systems. And that was a matter of milliseconds before they wanted to make a determination of like how many people had duplicate items in their shopping cart, and how many times was that deliberate, and how many times was that a mistake, so that they could prevent all of the downstream costs of shipping out duplicate items to their customer base. And in all of this, the biggest goal that the e-commerce retailer had here was to make sure that the customer experience was not suboptimal, and that anytime they came to their website, even if because of whatever reason or whatever glitch, they had duplicates in their shopping cart, that analysis would essentially help them pinpoint the actual root cause of where this problem actually started, and then be able to essentially tailor the supply chain, if you will, in a way that the problem would not result in a bad customer experience.
Thank you. So we have a question about it's a pretty short one and straightforward. What happens with data federation? And quote, what didn't work? So and I'll expand that. I'm not sure if the questioner meant this exactly, but the whole notion of data virtualization, where we have kind of a single broker but multiple data sources, a little bit antithetical to what we're talking about. Sachin, what do you, and feel free to be kind of partisan if you feel strongly, but what do you feel are kind of the upsides and downsides of a data virtualization approach, where we can kind of harmonize separate data sources by virtualizing their integration?
So the first thing that comes to mind over there is the fact that I have to now go ahead and create a brand new infrastructure layer that's going to virtualize all of my my data assets. So, and then there is this whole notion of like, in addition to being able to create that virtualization layer, how do I monitor and manage it? And then how do I make sure that that virtualization layer is connected to all the disparate data sources that I have? When we're talking about simpler transformations, or we're talking about analytics that involves what is sitting inside of your application. Let's say instead of the e-commerce example that I've been using, let me use the example of a baseball team, in fact, Cincinnati Reds, that is right now using what we've got and essentially transforming their whole fan experience. And by that, what I mean is, anytime fans come into the Cincinnati Reds stadium, they essentially are getting seated on their space, and then they have a live map of how traffic is sitting inside of their stadium, and then based off of that, they can essentially optimize the placement of food carts within the stadium. So instead of a customer having to walk half a mile, or let's say, I mean, depending on how big the stadium is, maybe a couple of 100 meters to the food cart, they're essentially able to figure out a way in which they don't have to make a long walk, and like in a few steps, the customer is at the food cart and is able to essentially place the order for whatever beverage or food item they would like. Again, the approach there is essentially getting all of the data in one single system in a matter of milliseconds. Again, the rapid time to ingest is a big part of being able to derive or glean insights from a rapid time to insight. And then the ability to essentially build a real-time decision system on where to place the cards. So again, it's a long-winded answer to the fact that with a data virtualization approach, what you'd have to do over here is essentially go into a completely different tangent, if you will, on creating a virtual layer, and then get into the process of maintaining that virtual layer, as opposed to working with the application data as that data is getting generated.
All right, fair enough. And that brings us to another poll. And here we're talking more about near future than present tense. Well, some of it's around planning, and some of it is also just around preference. So here we want you to select one particular answer rather than several. And this is all about operational analytics and the separation or union of OLTP and OLAP. So choices include the fact that you may feel fine with having things separate. And again, you know, I was, I guess, telling a few shark stories, but when things are set up separately and the pipelines are set up and the jobs work, that may not be ideal, but it's a lot better than not having an analytics layer. And to some extent, if you've got analytics and it's working, that's good by itself. So maybe you're in that camp. Maybe you're in the camp where right now they're separate, but you really want to unify them, either because what we talked about today is incredibly appealing to you, or because you were kind of predisposed to agree with that approach beforehand. Third option is that sometimes doing operational analytics in situ, in-place analytics in the operational database works, and for other workloads or analyses, maybe a dedicated platform you feel is well. So rather than choosing A or B, you choose both. And then finally, maybe you're already convinced of unifying these and you've already done it. So those are the four choices. Separate, but we want to unify them. We want separate and unified, or not only do we want unified, but we've done it already. Select just one, and we'll wait for your responses to come in. Sachin, kind of what have you seen out there in the wild? Is there a lot of A's and B's?
There is a lot of A's and B's, and what I've come across more is the B's, where they do have OLTP and OLAP, OLAP and OLTP, and what they want to do is go through the process of making that whole process simpler. We use a term called layer consolidation here at Couchbase, and I think that's essentially what most of the customers that I've spoken to are trying to do. And as a part of that layer consolidation process, they're also trying to see, as a part of that consolidation process, if that makes their whole pipeline a lot more simpler, if you will. Because managing data and having multiple formats of the data, given how cheap the storage is not an issue. But the whole process of taking data, transforming it into a different state is where most customers are running into challenges.
Actually,
sorry,
go ahead, but we have an audience question that ties into what you were just talking about, so I'd like to share it with you, but go ahead and finish your thought. I'm sorry.
Yeah, no, the other thing that I'm most interested in is if there are people in the audience who've implemented operational analytics already, and I think what would be very fascinating for me personally would be the architecture in place and the total cost of ownership of having implemented operational analytics already, because that's a key consideration for any analytics leader that is trying to bring these two disparate worlds together. On how much does it cost for me to bring those two together?
Understood. So here's the question, and if you feel it's a little loaded, say so. I was taken, I don't want to say taken aback, but I wasn't quite sure how to parse it. But here's the question: what's the difference, or what are the differences between ETL and data pipelines? I use them kind of interchangeably. Let me just get in front of that. But is it fair to make a distinction? And if so, how do you see that distinction?
Andrew, that's a very interesting question, and I am in the same camp as you are. And based off of all of the customer conversations that I've had, I've seen the two terms used interchangeably as well. The only thing I would say slightly different with the data pipelines is that many times, instead of the traditional extract, transform, and load, the ETL process, organizations are moving more towards the ELT, where they're like, let's extract the data and load it. And then we worry about transforming it once we've loaded it into our, for instance, data lake. So in many cases, the term data pipeline is being used to broadly describe both the ETL and ELT processes, and it's slightly broader than ETL in that front. But other than that, I've been using the term interchangeably, and that's the key takeaway that I've had from all of my customer conversations as well.
Yeah, I guess some of it, the pipelining is really about moving it and not necessarily transforming it. And ETL definitely is about transforming it. And I suppose if you move it without transforming it, then that probably does put you into an ELT or a schema on read scenario where you're going to be imposing structure on it at analysis time rather than at the time that the data moves. I think it's high time we take a look at the results of the poll now. So I'll go ahead and ask the team to put those up on screen. And no one feels that keeping things separate is okay with them. I think in the lead is just what you said, Sachin, kind of option B. Well, it's a tie actually, that there's separate, but they want to unify. And an equal number have already done that unification. Wow, that's a more kind of forward-looking and modern group of folks than I might have expected. So congratulations. I think that's great. There are some who say that both approaches are appropriate. That's we're at about half of the other two. So, and that does add up to 100%. So that's good. Any surprises there for you?
Actually, I think I'm quite surprised by option number D over there, where there's, I think in the lead is the fact that there are already people who've implemented the operational of bringing together the operational and the analytical workloads. And I think this kind of ties into the question that I asked before we got the results of the poll, which was there is approaches possible to essentially bring those two different worlds together. And of all the different approaches that are in there, I think one of the big questions, key questions being asked is, what is the total cost of ownership of putting something like operational analytics in place? And that is a key consideration as we begin to see more and more organizations embark on this journey of unifying their OLTP and OLAP workloads.
Yeah, I think probably the spread of columnar indexes and columnar tables, even in straight up relational databases, may have led to some of that, because that does allow for star join and basically queries with big group by aggregations in them to execute much more efficiently. Probably more in a data mart scenario than a more typical data warehouse scenario. But what's nice to see in the industry is that even the proponents of one extreme view or the other, everyone's kind of moderating and understanding that it's really a spectrum and not a bunch of discrete positions. And people are doing their best to kind of bridge and hybridize. But that's harder for older platforms than it is for some of the NoSQL platforms, which really could be designed with a lot of this in mind rather than as an afterthought. Does that resonate with you?
Yeah, no, it absolutely does. In fact, I think I wouldn't want to ignore the 20% of the respondents out there who have said that they prefer operational and dedicated analytics. They'd like to keep some part of it conjoined and the other part of it completely separate. And that's also a very interesting view of how some of the analytics leaders are thinking about the whole notion of bringing these two disparate systems together, where I think it resonates really well with me personally, because in that case, what you're doing is, for my high value data, for stuff that my applications care about, I want to have unified operational analytics and bring together my operational and analytical workload in a single platform. But for stuff that requires me to get access to, let's say, all the data from the last 20 years or 30 years, I'd prefer to keep that as separate analytical systems that are dedicated just for that kind of analysis.
Yeah, I think there's a lot of kind of analytical stuff that is, I mean, the questions are the same over and over and over again. When you get very routine, sometimes a cube or a warehouse can feed that nicely, but for exploratory stuff, that gets a lot harder. Let's move on to the next slide, though, and let's talk about some of the features and the benefits of this combined approach. I'll let these little items on the slide speak for themselves, but if you could maybe, there's a couple of things in here that are not so straightforward, like the whole role of change data capture techniques and how that can help here, caching and so forth. So I'm almost tempted sometimes to look at caching and say, well, that's just someone who wants to, have their cake and eat it too. It just said, let's keep everything in one place, but really a cache is a copy. I'm being controversial there on purpose. I'm trying to provoke you a little bit, admittedly, but give us a sense for architecturally how Couchbase handles this idea of, on the one hand, wanting to put everything together, and on the other hand, understanding that some separation is still required.
Yeah, so I think the first point over there, which is the same data but different compute, that's the key one from our perspective, and that's where Couchbase has architectural differentiation in the approach that we've taken. The data remains the same. If you're storing JSON, it's always JSON in and JSON out. And we are unique in the fact that even from an analytical perspective, we allow you to analyze JSON data in its natural form without any transformation. What does that really mean, and how do we do it? That's where the different compute part comes in, where for analytical processing, we have an MPP engine, or a massively parallel processing engine. Again, for those of us who are from the database world, MPP is not new. In fact, I think big products like Teradata, HP Vertica, again, have exemplified how MPP needs to be implemented in the world of relational flat data, normalized data. Now, the challenge is that, and there's a lot of research that's gone into it, and what we've done in Couchbase is essentially bring that research over the last 30 years or so and apply all of the best practices that people have learned in the relational world, but apply that to JSON data in its natural form. So the ability to distribute query processing across multiple nodes and then get the results back and provide them to the requester is where we differentiate ourselves in being a MPP engine for parallel processing of the same JSON data that you're storing as a part of your operational application. Now, being a part of the same platform, we're essentially able to move data really, really quickly. In fact, Couchbase is well known for performance, security, and scalability and availability. And the reason we have those tenets is because we have a way to essentially move data over from one node to the other using what we call a database change protocol, which is essentially the same thing as change data capture. And that's how we provide high availability, or the high performance in a standard architecture. And we extend that approach and essentially bring the exact same methodology for making the data available and optimized for analytical processing. The other thing we do is we do realize that, and this has been, again, one of the things where Couchbase has taken a completely different approach. Yes, we are a NoSQL platform, and NoSQL means not only SQL. So we do give you API-based access to all the data that is sitting in the Couchbase database. But if you're coming from the SQL world and you're familiar with the SQL language, then we essentially give you the ability to bring those SQL skills to this brand new schemaless world of JSON documents in NoSQL and run those queries just like you would using standard SQL on a relational system. And then the most important part over here is that because the data is being stored in its natural format and there is no transformation of that data. So which means that if you added new attributes to your customer's profile after 2 years of launching that service, and then any records that any customers who haven't come to your website in the last 2 years may not have those new attributes, that is totally fine. There are constructs that are available in the platform that would allow you to deal with data that is sparsely populated, values that are missing, and so on and so forth, which essentially allows you to work with data without doing any sort of ETL. And that brings us to the last slide. This is an ideal architecture for what operational analytical system would essentially look like. There are business applications that are generating a bunch of JSON data. And if you notice, right below that arrow is a nested structure over there, which essentially is our way of representing that JSON going in. And then that is going into a dedicated node that is optimized for operational workloads. And what you're storing in your data platform is essentially the JSON itself. And that same JSON is also made available using change data capture, or DCP in Couchbase lingo, on analytical nodes. These analytical nodes are custom built for analytical processing and can actually run.
Sorry, but I have a part-time job as an acronym policeman. Does BCP stand for bulk copy, as I know it from the old days, or does it mean something else?
No. So DCP is database change protocol. So it's the
sorry. DCP. Got it.
DCP. It's the implementation of change data capture within Couchbase. So from a platform perspective, using change data capture, we're essentially making that data available for analytical processing as well. And this is really, really simple to do on Couchbase because you can do this in 5 clicks or less using the Couchbase data platform. And what that lets you do is from an analytical team perspective, in the end, you have a bunch of analytical tools, visualization tools that are sitting within your enterprise. So you can connect the analytical nodes to the Couchbase analytical nodes or whatever analytical nodes you've got deployed within your enterprise to your tools without worrying about your operational workloads getting impacted in any ways. And again, the translation of many of the analytical tools, for example, Tableau or Looker for that matter, do not support JSON data. In fact, they work very well with relational data. So there's this whole translation layer that needs to be built in, or there's a driver that is required for essentially taking this nested hierarchical data on the JSON side and converting it into the flat relational structure that these tools would understand. And that would essentially allow you to, as new data is coming in, I like to think of this in the context of a connected car example, if you will, where your business application is essentially a bunch of cars. And think about like hundreds, thousands, millions of cars that are generating data every millisecond, maybe less than that, and sending the data over to your operational data nodes. And then anytime you want to do any sort of analysis on that, you can run that analysis based off of all the data that is coming in and essentially get up-to-date information on how your fleet of cars on the road is performing.
Got it. So, and you know, this diagram actually, I'll full disclosure, it does come from some of your collateral at Couchbase, but it works universally. Maybe that little bit of the kind of nested structure is particular to you, but this is the ideal we want to go for, right? That the business application and the analytics tools are drawing from the same reservoir of data, if you will, and that change data capture or a data capture protocol in your case is more of a passive listener to create a cache of the data than a brittle, complex sort of data pipeline that has to move that data and transform it and rewrite it and so forth. So there is a way to have the dedicated resources on the other hand without the mismatch and I don't know, the context switch, I suppose, of going from a dedicated operational platform to a dedicated analytical one. You can still use different tools. You can still execute rather different workloads. You can still go from, you know, looking at individual transactions or interactions to aggregational dimensional analysis. And even if those things are different, that doesn't mean that you need an entirely separate repository. Please correct me if I got anything wrong there, because we have to say goodbye shortly.
Yeah, no, I think you hit the nail on the head. That's the way I would describe it as well, Andrew.
All right, well, terrific. Hard to believe the hour's gone by, but it has. We're at the end of another webinar here, and we're glad to have you. I direct that to the audience, but also to you, Sachin. This was a good discussion. As I said, it comes up in a number of contexts, so I'm glad we could really drill down on it. And that brings us to the end of the webinar. I'd like to wish everyone a good rest of their morning, afternoon, or evening, depending on their location on the globe. Thanks, everyone. We'll see you on the next webinar.